Hello, Geometry. We're going to start Unit 4, Lesson 8 with problem 8.2. So here we go. What we want to do is we are asked to find the value of the variable for the problem, for each of the problems in the chart below. We'll start with column A. I'll do all three column A, and then we'll go back and we'll do all three column B. So here we go. So I'm looking for the value of x in this first triangle. What I recognize is that in this triangle, x is my hypotenuse, and I recognize that I have a 41-degree angle, and I also recognize that the leg that has a length of 7 is the leg adjacent to my given angle. So I need to think about SOHCAHTOA. If you remember, we had talked about SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. I need to find which one of these trig ratios has adjacent and hypotenuse together, and that happens to be cosine. So I can go to my problem and I can say that the cosine of a 41-degree angle is equal to the length of the side adjacent, which is 7, divided by the hypotenuse, which is x. Now I solve this. Remember, I have a variable and a fraction. Anytime I have a variable and a fraction, what I need to do is get rid of that denominator by multiplying both sides of the equation by the denominator. That cancels the x on the bottom, and on the left-hand side I have x times the cosine of 41 is equal to 7. Now I divide both sides by that cosine of 41 degrees, and I get x is equal to whatever 7 divided by cosine of 41 degrees is. Now I can go to my calculator, and I need to calculate 7 divided by cosine 41, and I get a value of 9.28. Okay, moving down, same type of situation. I have my angle of 65 degrees. I have the hypotenuse is 6, and I have now the opposite is y. Opposite and hypotenuse go together with sine. So I know that the sine of 65 degrees is equal to the opposite, which is y, divided by my hypotenuse of 6. Solve this by multiplying both sides of the equation by 6. 6 times the sine of 65 degrees is equal to y. So y equals, back to my calculator, 6 sine 65, 5.44. Last question in column A. I have this 50-degree angle, and I know that the 8 is opposite, and the z is the hypotenuse. Again, this is a sine because sine of an angle is equal to the length of the side opposite divided by the hypotenuse. Multiply both sides by that denominator. 8 is equal to z times the sine of 50 degrees. Divide both sides by the sine of 50. And I get my z value is equal to 8 divided by sine 50. To the calculator, 8 divided by sine 50, 10.44. Perfect. Now to column B. Looking for this x value, there's a 49. The x is the hypotenuse. 7 is now the opposite. Opposite and hypotenuse is sine. So sine of 49 is equal to the length of the side opposite divided by the hypotenuse. Multiply both sides by the denominator. X times the sine of 49 is equal to 7. Divide both sides by sine of 49. X is equal to 7 divided by the sine of 49 degrees. To my calculator, .28. Moving down, I have this 25-degree angle. The y is the adjacent. The 6 is the hypotenuse. So the cosine of 25 is equal to the adjacent divided by the hypotenuse. Multiply both sides by 6. The 6's on the right cancel. So my y is equal to 6 times the cosine 25 degrees. Enter it into my calculator. I get 5.44. Last one. I see my 40-degree angle. The 8 is the adjacent. The z is the hypotenuse. So the cosine of 40 degrees is equal to the length of the adjacent divided by the hypotenuse of z. Multiply both sides by that denominator. Z times the cosine 40 degrees is equal to 8. Divide both sides by the cosine of 40. Z is equal to 8 divided by cosine 40-degree angle. 8 divided by cosine of 40 gives me 10.44. Okay, now what we're asked to do is compare our solutions in column A to those in column B. So we're going to compare these solutions. Notice my x value in column A for the first triangle is 9.28, but it's also 9.28 in the other triangle. My second set of triangles in both columns have the same value for the variable, as do my third. So I notice that the solutions in A match the solutions in B. And why is that? So if we look at each of these triangles, what I would like you to notice is that the triangles are congruent. They're the same triangles. We just have different acute angles marked. So the triangles are congruent with different acute angles marked. And then in the next video, we're going to start discussing that and why that is the case.